Hi everyone. Today we're doing notes for 6.1, graphs of probability distributions. The normal curve. The curve is bell-shaped with the highest point over the mean mu. The curve is symmetric, about a vertical line through mu. The curve approaches the horizontal axis but never touches or crosses it. The inflection or transition points between cupping upward and downward occur above mu plus sigma and mu minus sigma, or the mean plus or minus 1 standard deviation. The area under the entire curve is 1. So again, looking at the picture here, again, mu, this represents the mean. This one is mu plus sigma. So this is the mean plus 1 standard deviation. We see mu plus 2 sigma is the mean plus 2 standard deviations. This should say mu plus 3 times sigma. That got cut off. And this is the mean plus 3 standard deviations. We can see on the other side it's the mean minus each of those same intervals. So identifying mu and sigma on a normal curve. So we're looking at the distributions on the side here, and it says, do these distributions have the same mean? If so, what is it? So we can see here that both of these distributions are centered around the same number. So yes, they do have the same mean, and we're wondering what it is, and we can see that this vertical line comes down, and they're both centered here at 6. So this is our mean mu. One of the curves corresponds to a normal distribution with a standard deviation of 3, the other to one with a standard deviation of 1. Which curve has which value for sigma? I want you to try to figure this out now. So for this one, sigma equals 3. This is actually going to belong to B. Our sigma that's 1 belongs to graph A. And this is because if we look at the two curves, B is more spread out, which means, so that has a larger sigma or standard deviation. The average amount it deviates from the mean is more, causing the graph to be more spread out. We have an empirical rule, and this says for distribution that is symmetric and bell-shaped, in particular for a normal distribution, approximately 68% of the data values will lie within 1 standard deviation on each side of the mean. So I'm going to highlight over this. So again, 68% is within 1 standard deviation. So I'm going to highlight, we have a line here and here. We have 34 and 34 together gives us this 68% between plus or minus 1 standard deviation. Our next one is approximately 95% of the data values lie within 2 standard deviations on each side of the mean. So draw lines here, breaking these off. So this is within 2 standard deviations. Again, this is 95%. So if I subtract out my 68 and divide by 2, that leaves us with 13.5 on either of these sides for that small section. We can see that if we add 13.5, 34, 34, and 13.5, that gives us our total of 95%. The next one, approximately 99.7, or almost all of the data values will lie within 3 standard deviations on each side of the mean. So we're out to here now. And this is within 3 standard deviations, our 99.7. Okay, so that's an additional 2.35 on each side. And then remaining on the very outside, so we see we have this 0.15%. That last little bit adds up to a total of 0.3% is left. That is outside of 3 standard deviations within the mean. So, Economic Internet Service has user connection times that are normally distributed with a mean mu is 5 seconds, and a standard deviation, sigma, of 1.5 seconds. What's the probability that a connection selected at random takes from 5 to 6.5 seconds? So again, our mu is 5. If I have mu plus sigma, that's 5 plus 1.5, which is 6.5. So that is going from the mean to one standard deviation on one side. So that's half of that 68%. So this is a total of 34% or 0.34. All right, the yearly wheat yield per acre on a particular farm is normally distributed with a mean mu is 35 bushels and standard deviation sigma is 8 bushels. Label the curve with the standard deviations in terms of bushels and shade the area under the curve below that represents the probability that an acre will yield between 19 and 35 bushels. Okay, so our mean is 35. So we're going to start by labeling. Remember, mean goes in the middle. And our standard deviation sigma is 8. So remember, this is mu plus sigma, mu plus 2 times sigma, mu plus 3 times sigma. So adding 8 each time, this is 43, 51, 59. Then we go and subtract to fill in the left. This is mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. So subtracting 8 from the mean each time, this is 27, 19, and 11. Okay, so now I'm going to drop vertical lines here to fill in the rest of our curve. Okay, and we are supposed to, so let's finish labeling. So we know that 68% goes between one standard deviation, plus or minus. We also have 95% goes within 2 standard deviations. And then we have our 99.7% goes within our 3 standard deviations. Okay, and it says we're supposed to shade the area under the curve that represents the probability an acre will yield between 19 and 35 bushels. All right, there we go. Okay, so is the area the same as the area between mu minus 2 times sigma and mu? Well, yes, we can see that is the same area. Find the percentage of area over the interval between 19 and 35. I want you to find this. Okay, so we know that half of 68, this is 34%. And then I know if I take my 95, split that in half, and then take out the 34, this leaves us with 13.5% here. Okay, so we can add up the 13.5 plus 34, and that's going to give us 47.5%. We can also simply just take 95% and divide that by 2, which also gives us 47.5. 4 says, what is the probability that the yield would be between 19 and 35 bushels per acre? So this one is going to give us just the same thing that we just drew in the picture. So our probability will be 0.475. All right, what does a normal distribution tell us? If a continuous random variable has a normal distribution, then the area under the entire distribution is 1. The area over a specified interval of values from A to B is the probability that a randomly selected variable falls between A and B. The distribution is symmetric and mound shape and is centered over mu. Most of the data, 99.7%, range from mu minus 3 times sigma to mu plus 3 times sigma. All right, here's our next practice. Rhode Island red chicks. The incubation time for Rhode Island red chicks is normally distributed with a mean of 21 days and a standard deviation of approximately 1 day. Look at the normal curve with percentages and answer the following questions. If 1,000 eggs are being incubated, how many chicks do we expect will hatch? So we need to create this normal curve. So again, we have this is our mean, and then mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. It says here our mean is 21 days, so 21 goes under mu. Standard deviation is approximately 1 day. So going to the right, we're going to add 1, 22, 23, 24. Going to the left, we're going to subtract 1, 20, 19, 18. Okay, then we can answer our questions. So it says, actually, let's go through and fill in our percents first. That will help us. Okay, so remember, within 1 standard deviation, this is 68%. Within 2 standard deviations, we have 95%. And with 3, we have 99.7%. Okay, A says, how many chicks would we expect to hatch in 19 to 23 days? So if we're looking at 19 to 23 days, we are looking at here all the way to here. So we're looking at our mean plus or minus 2 standard deviations, right? Because we went from mu minus 2 sigma to mu plus 2 sigma. And so we can see from our label here, this is going to be 95%. And then it says if 1,000 eggs are being incubated, how many chicks do we expect will hatch? So I can do 0.95 times 1,000, which gives us 950 chicks. Okay, next one says 20 to 22 days. So now we're looking from 20 to 22. So this one looks like we have mu minus sigma to mu plus sigma. So our mu plus or minus 1 standard deviation. Well, we know that represents 68% of our data. So I can do 0.68 times 1,000, and that's going to give us 680 chicks. I want you to try C, 21 days or fewer. If I'm doing 21 days or fewer, that's everything from here to the left. So that is everything from mu and below. So our mu is our mean. It's our middle or 50th percentile. So if it's everything below that, that's going to be 50% of our data. So we can do 0.5 times 1,000, which comes out to give us 500 chicks. Last one I would like you to do also, 18 to 24 days, assuming all eggs eventually hatch. If we're talking 18 to 24 days, we're going from here all the way through up to here. So we're going mu plus or minus 3 standard deviations, which means this is going to represent 99.7% of the data. So we can do 0.997 times 1,000, and that's going to give us 996 7 of those 1,000 eggs. Okay, again, if it helps for C, you can also think about adding a line and saying everything from here to the left represents 50% of your data. Okay, and note, well, it's just a single day. All right, and that's where we're going to end today.